guys, our lesson today is volume of spheres, and this is still under the same unit, measure 2D and 3D figures, and this is module 12, lesson 12.8. And our learning target, I can use the formula for the volume of a sphere or hemisphere. Okay, so I'm just showing you the two of them, sphere and hemisphere, to find the volume of the figure given its radius or diameter. And the vocabulary that we are going to be learning is hemisphere and sphere. So here is a model of both of them. Okay, so this is a sphere and this is a hemisphere. All right, so look, the hemisphere is what? Half of the sphere, right? So just wanted to show both of these to you. This is a hemisphere and this is a sphere. Okay, now let's quickly talk about what is this. And I've drawn one on the board. Obviously, it's not going to be as circular as this is with freehand, but okay, so that's what I've drawn. And as what is this? A sphere is a set of all points in space that are a given distance known as the radius from a given point known as the center. Okay, and so when I look at the volume of a sphere, everything that this is occupying, all right, so the volume of a sphere is 4/3, okay, 4/3 the product of pi, okay, and the cube of the radius, so r cubed. So if I'm writing this down as an equation, volume is 4/3 pi r cubed. Okay, and let's solve a problem in order to understand how to find the volume. Let's say I have a sphere, and over here my radius is provided as 6 millimeters. So let's say this is what the radius is provided to me. Express your answer in terms of pi. Okay, so when I'm looking at this, I've already written out the formula for the volume of a sphere, and the volume of a sphere is what? It is 4/3 pi r cubed. Okay, a radius has been provided to me. So all I'm going to do now is substitute the value, because it's saying leave your answer in terms of pi. Okay, so I'm going to do volume is 4/3, okay, pi times what is r is 6. So 6, which is going to be cubed. Okay, and so when I do this, I get 6 times 6 times 6, okay, and I multiply that, and then when I simplify, I'm going to get you know, 288 pi. I'm going to get 288 pi in terms of pi. That's what this means. Okay, so 6 times 6 times 6, and then times 4 divided by 3, and I am going to end up with this as my volume in terms of pi. So the volume of the sphere is 288 pi cubic millimeters, because everything in volume is cubic. All right, so you can write it as cubic millimeters this way. You can also write the unit like this, millimeter cubed. So that is another way of writing it. Okay, now let's talk about, let's say I have a cube with a radius of, okay, let's say I have a cube with a radius of 1 inch. Okay, and I have another cube which has a radius of 2 inches. All right, so what do you notice about the relationship between the volume of a sphere with a radius of 1 inch and the volume of a sphere with a radius of 2 inches? Do you think this relationship always exists when a radius is doubled? Okay, so let's quickly go ahead and do the calculation of these two so that you can see. And we know that volume is what? It is 4/3 pi r cubed, right? Volume is 4/3 pi r cubed. And radius in the first one is 1. So this is going to be volume is 4/3 pi times 1 cubed. And 1 times 1 times 1 is 1. And so then I'm left with volume is 4/3 pi. Okay, so this is the first one, and this is like, let's say, inches cubed. All right, inches cubed. So this is my volume when it is 1 inch. Okay, let's look at what happens when I double it. And so now I'm going to do volume again is 4/3 pi r cubed. So volume is 4/3 pi, and now r is 2 cubed. That's 2 times 2. 4 times 2 is 8, right? So volume is 4 pi times 8 over 3, which gives me, what is 4 times 8? Is going to be 32. So 32, right? Pi, so 32 over 3 pi. So look at that now, inches cubed. So this is what happens when I double it. So it was 1 inch, it was 4/3 pi, and when I doubled it from 1 to 2 inches, it's 32 over 3 pi inches cubed. Okay, so the volume of a sphere with a radius of 2 inches is 8 times greater than the volume of a sphere with a radius of 1 inch. So it was asking, earlier that do you think this relationship always exists when a radius is doubled? So yes, because when the radius is doubled, 2r cubed is 8 times as great as r cubed. Because what is 2 cubed? 2 cubed is going to be 8. All right, so that is one thing I just wanted to show you the relationship. Let us go ahead to the whiteboard really quick and look at this problem. Okay, and so it's saying a spherical stone found in Costa Rica has a diameter of about 8 feet. Find the volume of the spherical stone, round to the nearest tenths. So first thing we have to look at what is provided to us and how do we find the volume of a sphere. Okay, so I know that volume is 4/3 pi r cubed. Okay, so volume is 4/3 pi r cubed. Okay, and now you've got a stone in which the diameter is given. And diameter is what? Twice the radius. So we need to find radius in order to solve this. So my diameter is twice the radius. So if diameter is 8, diameter divided by 2 is going to give me the radius, right? So diameter divided by 2 gives me the radius. And so radius is going to be 8 divided by 2. And so I get my radius as 4. All right, so now I'm just going to substitute the values and I'm going to say volume is 4/3 pi, and what is the radius that I calculated? It is 4 cubed. It is 4 cubed. So 4 times 4 times 4. Okay, and so then when I simplify this and I do 4 times 4 times 4. Okay, 4 times 4 is 16, times 4 is 64, times this 4 up there, and I get 256 over 3 pi. Okay, and then when I use a calculator, I am going to change my equal to sign of a volume to approximation because the value of pi is an approximation, and I end up with 268 and 1/10 cubic feet. So here is my volume. Okay, volume of the sphere is about 268 and 1/10 cubic feet. Now, the question is, why in the case of an actual spherical object made of stone or another material, is it best to report the volume as an approximation and not in terms of pi? So think about it. What is pi? Pi is an irrational number, right? Pi is an irrational number. And so it is best to use the decimal approximation to understand the measurable amount of material in an object. So that is why you need the decimal version to understand the measurable amount in an object. And that is why we went ahead and use the approximation of pi. We use the decimal numbers in order to calculate. Okay. Let's do another problem. And let's look at this one. Okay. So in this, it's saying a training volleyball has a diameter of 10 inches. If the diameter is 10, what's the radius? Radius is going to be half of 10, which is 5. Okay. A pump can inflate the ball at a rate of 325 cubic inches per minute. How long will it take to inflate the ball? So let's look at this one. And so first we're going to find the volume of the volleyball. Okay. So volume is 4/3 pi r cubed. Okay. And so if the diameter is 10, as I said, two radiuses make a diameter. So I'm going to divide that by 2. And my radius is going to be 5 because I need my radius for the calculation over here. Okay. So therefore, volume is equal to 4/3 pi and 5 cubed. So 5 times 5, 25 times 5, 125. So that's what this portion is. Times 4. And then we're going to change it from this to an approximation because I am going to do the calculation of pi to get a measurable amount. Okay, so 5 times 5 times 5 times 4 times pi, because I want the decimal version, and then divided by 3. So I get 523 and 6/10 cubic inches as the volume of this. Okay, so next it's saying a pump can inflate the ball at a rate of 325 cubic inches per minute. How long is it going to take to inflate the ball? So what I'm going to do now, I'm just going to write and solve a proportion to find the time to inflate the volleyball. Okay, so I am going to round the volume to the nearest tenth, which I've done here. And then let's look at the first one. It said 325 cubic inches, 325 cubic inches in 1 minute. So I'm writing an equivalent ratio. I'm trying to make a proportion so it becomes easy for me to calculate. Okay. And so this should equal 523 and 6/10 inches. 523 and 6/10 inches cubed, which is the volume I just calculated of this. Okay. Should be in how many minutes? Okay. Should be in how many minutes? So look how I have now set up a proportion. So this should equal this. Now there are several ways to do it. I can basically divide 523 and 6/10 by 325. Okay, so if I divide it, what do I get? I am going to end up with 1 and 6/10. So I know that there are several things I can do. I can go this way because it's hard to calculate otherwise. So if I divide, I am going to, if I'm dividing, I'm going to get 1 and 6/10. Okay, so whatever I do to the numerator, I normally do to the denominator. But if I am taking this arrow backwards, what is the inverse of division? It is multiplication. So that means I am going to do times 1 and 6/10. Okay, and so when I do times 1 and 6/10, I am going to multiply that, and so I am going to get 1 and 6/10 over here as my answer. Okay, so it takes about 1 and 6/10 minutes. Okay, so 1 and 6/10 minutes. All right, or 1 minute and 36 seconds, 36 seconds to inflate the volleyball. Okay, so this is one method I taught you. You can also do cross products. That means 325 times x, which is 325x, is equal to 523 and 6/10 times 1. So ultimately what happens, you end up with again division, because you're going to do the division property of equality. Okay, this is what I'm saying. You could have done 325x if I'm doing cross products. Okay, is equal to 523 and 6/10. So because times 1. And then what am I doing? I'm just using the division property of equality, and I am dividing both sides by 325 in order to find x is equal to, when I divide, I am going to get 1 and 6/10. So that's what I was trying to show you, that there are so many ways. You could also do, if I'm doing times 1 and 6/10, I can do times 1 and 6/10 over here. But the reason I showed you division, because it's hard to figure out that this number is going to be times 1 and 6/10. So when you do the reverse of multiplication, that is division, it will be easy for you to figure out what I divided by. And so when I'm taking the arrow in this direction, it would be the opposite of division, which is multiplication. So then I would multiply that in order to get so many minutes. Okay, so this is how we calculate on this problem. Now, without calculating, how do you know that the time to inflate the volleyball will be greater than 1 minute? Okay, so because what happens, it takes 1 minute to inflate 325 cubic inches. And then when we are looking at the volume, which is going to be greater, right? The volume is greater than 325 inches cubed. So therefore, the volleyball will definitely take more than 1 minute in order to fill this up, because this volume is greater than this volume. All right, um, so here's the hemisphere now. And I just want to quickly talk to you about hemispheres. And so let me just come back here really quick. All right, so I want to show you the relationship between a sphere and a hemisphere. Okay, now we've said this is a sphere over here. Okay, this is the volume of a sphere. Okay, now once again, let me show you the two models. Okay, so this is my sphere and this is my hemisphere, which is half of that. Okay, so look, this is half of that. So therefore, because of that, when I take the volume of a hemisphere, okay, I am going to take half of 4, which is what? 2. So volume of a hemisphere is going to be 2/3 pi r cubed. 2/3 pi r cubed. So I just wanted you to see that relationship. So this is half of this, And so that is why that volume, it becomes from 4/3, it becomes 2/3. So a circle through the center of a sphere separates a sphere into two congruent halves, each called a hemisphere. Okay, so how are the coefficients 4/3 and 2/3? You know, in the formulas for finding the volume of a sphere and hemisphere related. How are these two related? Okay, so the coefficient in the formula for a hemisphere is half of the coefficient in the formula for a sphere. And that's because what I just showed you, what this is half of this. Okay, so now let's go ahead and solve the problem that we were going to. Now that we can understand that relationship of the formula between the two, we are going to find the volume of the hemisphere and we are going to round to the nearest tenth. All right. So, and this is going to be the last problem that we are solving in this lesson. And okay, so it said find the volume of the hemisphere and round to the nearest tenth. So we know that the volume of a hemisphere is what? It is 2/3 pi r cubed. Right? So if the volume of a sphere is 4/3 pi r cubed, half of that would be 2/3 pi r cubed, and that is the volume of a hemisphere. And so now we are going to replace, we already know how much the radius is, which is 5. And so I'm going to take 5 and I'm going to replace the r with that measurement that is provided. Okay? So volume is equal to 2/3 pi and 5 cubed. All right, so 5 cubed, which is, what is that? 5 times 5 times 5, 25 times 5, I get 125, which is just this portion, right? So that is this portion, which is 5 cubed. And what is 125 times 2? I am going to get 250. So volume is 250 over 3 pi. All right. And now what I'm going to do is I am going to use a calculator to find, changing the pi to the decimal version. And so now the equal to sign becomes an approximation. And so I get 261 and 8/10 cubic centimeters, and this is the volume of this hemisphere. Okay, so that's basically what this lesson is about, finding the volume of spheres and hemispheres. Please remember what I just showed you between these two. A hemisphere is half of the sphere. And so if this is 4/3 pi r cubed, the hemisphere is going to be half of that. So that's why it is 2/3 pi r cubed. And that's how we calculate the volume of spheres and hemispheres. Have a great day, everyone.